Hello, in this lecture we will find the radius of the circle enclosed in a triangle. Okay, actually we have in the drawing triangle ABC. Side AB of the triangle is 4 units, side BC equals to 3 units, and side AC of triangle ABC equals to 5 units. Inside the triangle we have a circle, and we also know that the area of the triangle equals to 6 units. Okay, so when we want to find the radius of the circle enclosed in the triangle. Okay, so first of all let's define the center of this circle as M. So let's call it O. So point O is the center of this circle. Okay, and let's define the touching point between side AB of the triangle and the circle as N. Point N is the point of contact between side AB of the triangle and the circle. Okay, or we can also say that side AB of the triangle is tangent to the circle at point N. In the same way, we will define the point of contact or the touching point between side BC of the triangle to the circle as M, or side BC of the triangle is tangent to the circle at point M. And let's define the touching point between side AC of the triangle to the circle as P. Okay, so side AC of the triangle is tangent to the circle at point P. Okay, and side AB of the triangle is tangent to the circle at point N. Side BC of the triangle is tangent to the circle at point M. Okay, O is the center of this circle. Let's connect together points N and O. Actually, line segment NO is the radius of this circle. I will mark it as small r for the simple reason that line segment NO starts from the center of this circle and ends at point N, that is a point on the circle itself. For that reason, line segment NO is the radius of this circle. Okay, in the same way we will connect points O and M together. And from the same reason line segment MO is the radius of this circle. I will mark it as R because it starts from the center of the circle, that is to say from point O, and ends at point M, that is a point on the circle itself. For that reason, line segment MO is the radius of this circle. And in the same way, we will connect points O and P together by a straight line. And again, line segment OP is the radius of this circle. I will mark it as small r because it starts from the center of this circle and ends at point P, that is a point on the circle itself. And the definition of a radius is any line segment inside the circle that starts from the center of the circle and ends at any point on the circle itself is defined as radius. Okay? For that reason, MO, NO, and OP are the radiuses of this circle. All of those three line segments starts from the center of this circle and ends at a point on the circle itself. For that reason, all those three line segments are radiuses of this circle. Okay? So, actually, we have a rule. I will call it rule number 1. And rule number 1 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. Okay, I will read again rule number 1. Rule number 1 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So if we have a radius, let's call it R, and we have tangent to that radius, let's call it T, then the radius is perpendicular to its tangent. That is to say, this angle is 90 degrees and this angle equals to 90 degrees also. Because in any circle, a radius is perpendicular to its tangent. The tangent to of this radius is this straight line, and for that reason, this radius is perpendicular to its tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. So in any circle, a radius and the tangent to its radius are perpendicular to each other. For that reason, this angle is 90 degrees and this angle is also 90 degrees. So actually we can implement rule number 1 in our circle. because actually we have here the radius, line segment MO is the radius, and side BC of the triangle is tangent to the radius at point M. Is BC actually it's tangent to the circle and is tangent also to the radius at point M. For that reason, angle OMB equals to 90 degrees, and also angle OMC equals to 90 degrees, because in any circle the radius is perpendicular to its tangent. The tangent of this radius is side BC of the triangle. For that reason the radius is perpendicular to its tangent. That is to say, angle OMB equals to 90 degrees and angle OMC also equals to 90 degrees. And in the same way, we have line segment NO, that is the radius of this circle, and we have tangent to that radius. Side AB of the triangle is tangent to that radius. For that reason, the radius is perpendicular to its tangent. That is to say, angle ONB equals to 90 degrees, and also angle ONA equals to 90 degrees, because the radius is perpendicular to its tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. And exactly for the same reason, line segment OP is the radius of this circle, and we have tangent AC, side AC of the triangle is tangent to this radius. For that reason, angle OPA equals to 90 degrees, and angle OPC also equals to 90 degrees, because the radius is tangent to the radius is perpendicular to its tangent. So this radius is perpendicular to tangent OC. For that reason, angle OPA equals to 90 degrees, and also angle OPC equals to 90 degrees. Okay, so in the next step we will connect points O and C together by a straight line. And we will also connect points O and B together by a straight line. And actually we created here triangle BOC. We have here triangle BOC. The green triangle is triangle BOC. So the area of this green triangle, the area of any triangle equals to the base of the triangle times the height to the base all divided by 2. Okay, so the area of any triangle equals to the base of the triangle times the height to the base divided by 2. Okay, or we can, instead of the area of a triangle, I will use the abbreviation A. A is for the area of any triangle equals to the base times the height to the base divided by 2. Okay, this is the formula for the area of any triangle, no matter if it is a right triangle or any other triangle. The area of a triangle is the base equals to the base times the height to the base divided by 2. So actually the area of the green triangle, or the A is abbreviation for the area of triangle BOC, that is the green triangle, equals to the base of the triangle. The base of the green triangle equals to 3, because it is given us in the question. So it is 3 times the height to the base. As you know, the height creates with the base 90 degrees. So as you can see here, the radius of the circle creates 90 degrees with the base. This is the reason that the radius of the yellow of the circle equals to the height of the green triangle. So the height of the green triangle equals to the radius, all divided by 2. Okay, so the area of the green triangle equals to 3, because it is the base of the triangle. BC equals to 3 units times the radius of the circle, because the height of the green triangle equals to the radius of this circle, because the radius creates 90 degrees with the base. Angle BMO equals to 90 degrees and angle CMO equals to 90 degrees, and this is exactly the definition of height. The height of a triangle creates 90 degrees with its base. So the height of the green triangle is R, so it is 3 times R divided by 2, and 3 over 2 is 1.5. So in total we got that the area of the green triangle equals to 1.5 units. Okay. In the next step, we will connect together points O and A. By a straight line. And we will focus on triangle AOC, that is the yellow triangle. So the area of the yellow triangle, triangle AOC, the area of the yellow triangle AOC will be equal to the base of the triangle that is given to us. It is 5 units times the height of the triangle, that is actually the radius of the circle, times r. Again, the height of the triangle always creates 90 degrees with its base, and the radius creates 90 degrees with the base AC, because angle OPA equals to 90 degrees and angle OPC equals to 90 degrees. So it is 5 times the radius, the height is the radius, divided by 2. Okay, so the area of the yellow triangle equals to 5 times the radius divided by 2. 5 over 2 equals to 2.5, so in total we got that the area of the yellow triangle equals to 2.5 units. Okay, 2.5 R units. Okay, this the area of the yellow triangle equals to 2.5 R units. Okay, because it is 2.5 times the radius, because the height equals to the radius. So in total it is 2.5 times the radius R. This is the area of the yellow triangle. And at the end we will calculate the area of the orange triangle. This is actually the area of triangle AOB. Okay, so the area of the orange triangle, that is triangle AOB, equals to the base of the triangle, that equals to 4 units, it is given us in the question, times the height to the base. The height to the base is actually the radius of the circle, so it is 4 times the radius of the circle, all divided by 2. Or the area of the orange triangle equals to 4 times the radius divided by 2, or in other words it equals to 2 times the radius. Okay, 4 over 2 is 2, is 2 times the radius. It is actually units squared. Okay, so the area of the orange triangle equals to 2 times the radius units squared. Okay, but actually the area of triangle ABC equals to the area of it is the sum of the areas of the yellow triangle plus the area of the green triangle plus the area of the orange triangle. The sum of those three triangles are equal to the area of the big triangle ABC, because triangle ABC contains exactly these three triangles. Okay, so the area of triangle ABC equals to the area of the green triangle, that is actually 1.5 r squared, plus the area of the yellow triangle, that equals to 2.5 squared, 2.5 r squared. Again, the area of the green triangle equals to 1.5 r squared, and the area of the yellow triangle equals to 2.5 r squared, plus the area of the orange triangle, that equals to 2 times r squared. Okay, so the area of the big triangle ABC equals to the area of the three triangles that each contains. The big triangle ABC contains the yellow triangle, the green triangle, and the orange triangle. So the sum of the areas of those three triangles equals to the area of the big triangle. Okay, so the area of the big triangle ABC equals to 1.5 r, that is the area of the yellow triangle, of the green triangle, plus the area of the yellow triangle, that is 2.5 r units squared, plus the area of the orange triangle, that equals to 2 times the radius, units squared. So the sum of those three areas, the area of the green triangle plus the area of the yellow triangle plus the area of the orange triangle, equals to the area of the big triangle ABC. Okay, but it is given us in the questions that the area of the big triangle ABC equals to 6 units. Okay, so we'll mark it as a question number 1. So we can substitute the area of the big triangle ABC by 6, because it is given us in the question that the area of triangle ABC equals to 6 units. Okay, and 1.5 r plus 2.5 r equals to 4.r, and 1.5 r plus 2.5 r equals to 4 times r, and 4 times r plus 2 times r equals to 6r. Okay, so in total, in this side of the equation, we have 6r. So in equation number 1, we got that the area of triangle ABC, the big triangle, is 6 units square, and it equals to the sum of the areas of the green triangle, the yellow triangle, and the orange triangle. That in total they equal to 6 times r units squared. Okay, so we can divide the equation by 6. And we will get that the radius of the circle equals to 1 unit. Okay, So the answer to the question is that the radius of this circle equals to 1 unit. This is the answer to the question, and now I will summarize the lecture. Actually, we wanted to find the radius of the circle that inside the triangle. Okay, and we know that triangle ABC, the area of triangle ABC equals to 6 units, and we also know that side AB of the triangle equals to 4 units, side BC of triangle ABC equals to 3 units, and side AC of triangle ABC equals to 5 units. And as I've already told you, we also know that the area of triangle ABC equals to 6 units. And we asked in the question to find out the radius of the circle inside the triangle. Okay, first of all, we defined the center of the circle as point O, and we called to the touching point between side BC of the triangle to the circle point M, or side BC is tangent to the circle at point M. Side AB of the triangle is tangent to the circle at point N, and side AC of the triangle is tangent to the circle at point P. Okay, and I've already explained that line segment MO is the radius of this circle because it starts from the center of the circle and ends at point M, that is a point on the circle itself. For that reason, line segment MO is defined as the radius of this circle, and for that reason, for the same reason, line segment OP is also the radius of the circle because it starts from the center of the circle and ends at point P, that is a point on the circle itself. And from the same reason, ON is also the radius of this circle because it starts from the center of the circle and ends at point N, that is a point on the circle itself. And the radius of any circle is defined as a line segment inside the circle that starts from the center of the circle and ends at any point on the circle itself. And those three line segments actually answers exactly to the definition of the radius of a circle. They satisfied the definition of a radius of a circle because they already starts from the center of the circle and ends at a point on the circle itself. For that reason, line segment MO, line segment NO, and line segment OP are the radiuses of this circle. Okay, in the next step, we connected points O and B together by a straight line, and we connected also points O and C together by a straight line. And we created the green triangle. The green triangle is triangle BOC. And we know that the area before that we have rule number 1 that states that in any circle a radius and the tangent to that radius are perpendicular to each other. So if we have radius and we have tangent to that radius, the radius is perpendicular to its tangent. That is to say, angle OMC equals to 90 degrees and angle OMB also equals to 90 degrees because the radius is perpendicular to its tangent. BC is tangent to the radius and the radius is perpendicular to its tangent. For that reason this angle is 90 degrees and this angle is also 90 degrees. And for the same reason we have here the radius and we have the tangent to that radius. AC is tangent to this radius. For this reason this angle is 90 degrees and this angle is also 90 degrees, or angle OPA is 90 degrees and angle OPC is also 90 degrees. And for the same reason we have the radius and the tangent to that radius, and according to rule number 1 that I mentioned, the radius is perpendicular to its tangent. AB is tangent to this radius, so angle ONB equals to 90 degrees and also angle ONA equals to 90 degrees. Okay? And in the next step we connected together points O and B by a straight line, and we connected together also points O and C by a straight line, and we created the green triangle. Okay, and we actually know that the area of any triangle equals to the base of the triangle times the height to the base divided by 2. Or we can instead of the triangle we can use the capital A, that is abbreviation for area. So the area of that any triangle equals to the base times the height to the base divided by 2. Okay, and actually if we focus on the green triangle, the base of the green triangle BOC equals to 3 units. It is given us in the question. The base equals to 3 units and the radius and the height to the base, always creates 90 degrees with the base. For that reason the radius of this circle is the height of this triangle, because it creates 90 degrees with the base. So the height of this triangle is the radius and the base is 3 units. So the area of the green triangle equals to the base, that is 3, times the radius, that is r, divided by 2. Or the base of the area of the green triangle equals to 5 times the radius divided by 2, or 5 over 2 is 1.5. So in total the area of the green triangle equals to 1.5 units. Okay? The area of the green triangle equals to the radius, the base of the triangle, that is 3 units, times the height, that is the radius, divided by 2. So in total the area of the green triangle equals to 1.5 r units squared. And in the same way we calculated the area of the yellow triangle. The area of the yellow triangle equals to the base of the triangle that is given us, it is 5 units, times the height to the base. The height always creates 90 degrees with the base, and the radius creates 90 degrees with the base AC. For that reason the radius is the height of the yellow triangle. So in total the area of the yellow triangle equals to 5 times the radius divided by 2. Okay, the area of the yellow triangle equals to 5, that is the base of the triangle, times the height of the triangle, that is the radius, divided by 2. Or in other words, the area of the yellow triangle equals to 2.5 r units squared. Okay, and in the same way we calculated the area of the orange triangle. The area of the orange triangle equals to the base of the triangle, that is 4 units, times the height of the triangle, that is the radius, because the radius creates 90 degrees with the base. For that reason, the radius is the height of the orange triangle, divided by 2. So 4 times the radius divided by 2 equals to the area of the orange triangle. So the area of the orange triangle equals to 4 times r divided by 2, or 2 times the radius units squared. So we can say that in total, the area of the big triangle ABC equals to the sum of the areas of the green triangle, of the yellow triangle, and of the orange triangle. Okay? Or because the big triangle ABC contains those 3 triangles. So its area equals to the sum of the areas of those 3 triangles. Okay? But we know that the area of the green triangle equals to 1.5 r, and the area of the yellow triangle equals to 2.5 r, and the area of the orange triangle equals to 2 times r. So in total, the sum of those 3 areas will be equal to the areas of the big triangle ABC. But it is given us in the question that the area of the triangle ABC equals to 6 units. It is given us in the question. In the question itself, it says that the area of triangle ABC equals to 6 units squared. So actually we can substitute the area of triangle ABC by 6 units, because the area of triangle ABC equals to 6 units. Okay, so from this side of the equation we have 6, and from the other side of the equation, the sum of 1.r plus 2.5r is 4r, and 4r plus 2r equals to 6r. So we got the 6 equals to 6r. We can divide the equation number 1 by 6, and we got at the end that the radius of this circle equals to 1 unit. Okay, so the question was to find out the radius of the circle inside the triangle, and the answer to the question is that the radius of this circle equals to 1 unit. R equals to 1 unit. Okay, thank you very much.